Does everyone see that perfectly fine?
Yeah.
Okay, fantastic. Okay, so today we are here to talk about heat pumps. I, my name is Mike Reagan. I'm a commercial area sales manager for Mitsubishi Electric. I work directly with engineering consultants in the area in the design process for various commercial buildings and the upgrade of their systems to high efficient heat pump technology. So today, we're going to be going over a little bit of an introduction to the technology itself, explaining what heat pumps are. We're going to be talking specifically about their low ambient heating capabilities. We live in New England. It gets kind of cold up here, but that being said, we have these installations far up into Maine or even up into Canada. So they certainly boast quite a capabilities for being able to perform in low ambient temperature conditions. We're going to talk a little bit about integrating with any existing boilers or furnaces you may have. You don't outright need to replace the system you have today. You put our equipment in order to increase the efficiency that your home is experiencing and lower your utility costs. Charlie's going to talk about applying heat pumps to your actual homes and be able to walk through and envision exactly what this will look like in your house. And then we'll have a little question and answer session at the end. So let's start today. What is a heat pump? What is this term that everyone is throwing around? Well, very simply, I'm just going to read this verbatim because I can't possibly say it any simpler than this. A heat pump simply moves heat or energy inside or outside a building, depending on what mode the system's in. So here's kind of a depiction of exactly what goes on here. In the summertime condition, I'm going to start on the right. In the summertime condition, your house kind of works like a refrigerator. Just think of it, everything that gets hot in your refrigerator, it takes that heat and it spits it out the back. That's why if you put your hand behind your refrigerator when it's operating, it gets kind of warm back there. That heat is what is being taken from inside the refrigerator and pumped outside. So in the summertime, your house works the same exact way, except your house represents the inside of that refrigerator. And instead of pumping out the back of the fridge, we're dumping that heat outside. In the wintertime, that exact process occurs in reverse. We get the heat from the outside environment and we move that heat inside and deliver it into your home. You may be thinking, well, it's cold outside. There's no heat out there. We assure you, as long as it's above negative 30 degrees, which if we're getting colder than that, we got some bigger problems on our hands over here. But if it's above negative 30 degrees outside, there is heat to be gained and transferred inside. So let's take a look about exactly what this would look like in our home process. This is what a typical multi-zone system looks like. We have the outdoor unit that would be what's placed outside, and that's connected to a variety of indoor unit zones. Now, this shows four different zones. You could have four, you could have three, you can only have a one-to-one. If you have an air handler in your attic and that's what's delivering AC into your home today, we could be putting it directly in a one-to-one replacement with that particular unit and using that same ductwork to deliver that cooling and now heating as well into that space. So showcasing very similar to what we were saying before. In cooling operation, we're delivering cold refrigerant to these indoor unit zones. That cold refrigerant is going to go through your indoor unit and it's going to blow air over that cold refrigerant. And that's going to cool that air off. So when it blows into the space, you're getting cold air inside. And the process of blowing that air over that cold refrigerant, that's what's going to allow us to move that heat to the outdoor space and spit it out outside. Heating operation, as we said before, it happens exactly in reverse. We're going to be pumping hot gas into your home through the refrigerant piping in the system. We're taking the heat from the outdoor space and we're moving it inside and delivering it to these individual zones. So this will allow you to have independent temperature control in different rooms in your house. So if you have a bedroom, you could set that to 72 degrees, whereas a living room, you could keep it to 70. If people have different preferences throughout your home, you could have different temperature control throughout the space. Now, as said before, you can have this where you zone it. So you could have a fan coil in each individual space, or you could just have it one to one. We have the flexibility to do either. And really, what your home layout what looks like is what's going to determine how we're going to approach this. So we have a lot of flexibility based on what your home layout is and what your preferences are and how you want your home independently zoned. We have a diverse range of different types of equipment options. A lot of people, when they hear about heat pumps, they think about those wall-mounted units in the middle there. We have a great deal of flexibility to work with. So those wall-mounted units, that would be called a ductless style of a fan coil. We also have ducted. That air handler style that you have in your attic today for air conditioning, we have a version that does both heating and cooling. We have ceiling mounted units that is literally built into your ceiling. It can actually fit in between the joists in your ceiling as well. So that way it could just slide right up in there and it has minimal aesthetic impact. We could have a swap out of an existing radiator system with our floor mount equipment, et cetera. So Charlie's going to go into the details about how these apply to individual zones. So I'm just going to keep going here. So again, here's a depiction of how that ductless style of equipment is just integrated seamlessly into your house. Again, that could fit right in between those 15-inch joists for minimal impact, and you don't need to really cut into too much. It actually just fits right on in there. Here's some more examples. We have the wall mount style on the left. We have two ceiling cassette styles in the middle and the right, just to showcase that we have a lot of flexibility depending on what you prefer in your own space, as well as what is just most convenient for that system as a whole. And I do want to point out, this stuff is whisper quiet. So right now I'm talking at presentation volume. So I'm kind of projecting a little bit here. So I'm probably in the 60 decibel range in terms of how loud I'm talking. The indoor unit that will be in your home, that will be less than a third as quiet as I'm talking right now. It's as quiet as 22 decibels. And if we're talking about the unit that's outside, if you're barbecuing outside, you don't want that loud AC unit that shakes and like stuns you whenever it turns on all of a sudden. Nope, this one is going to be much, much quieter. This one's going to be operating to that it's pretty much just the sound of the fan operating, even in the middle of the summer. So now let's talk about efficiency. That's what everyone talks about when they're talking about heat pumps. So let's get into it. When we talk about efficiency, we're talking about how much energy output you're able to achieve based on how much energy you're inputting. And that energy you're inputting, it would be, the amount of natural gas that you're feeding into your furnace or the amount of electricity that you're feeding into your AC unit. So what makes heat pumps particularly efficient is that whereas with furnaces, with boilers, or with like potentially electric resistant heat, if you have those electric baseboards in your home, with those, you're generating heat. With heat pumps, you're actually transferring heat. That's where the name heat pump comes from. You're literally pumping heat throughout the system. With a furnace or a boiler, you burn that gas and there's some losses associated with that. If you have a high efficient furnace or a high efficient boiler, fantastic. You can get about, up to 95, maybe even 98% efficiency off of those systems. With a heat pump, you're able to get anywhere from 200 to 400% efficiency. And that's throughout a year. So with that, we're able to achieve much greater efficiencies in the heating season. Now, obviously, where this cost savings comes in is what your utility rates are. We have, the natural gas or oil or propane. Those types of heating sources are really quite cheap on a per unit basis. So we have had to increase our efficiencies with this equipment so much that is actually more cost effective to use an electric heat pump to heat and cool your property. So I'm going to get a little bit, this gets a little bit confusing, but go with me here for a second. This is going to demonstrate where the real efficiency value is with your heat pump versus a conventional AC system. The unit that you may have had in your backyard for the last, 10, 20 years or so, you may have noticed that if you're outside and that thing kicks on, it starts up loud. And that's because it all comes on in one speed. It's either on or it's off. So this black line here, that represents that old school style of system where it needs to turn on and eventually for this is going to represent heating. It's going to turn on, it's going to overheat that space, and that's going to turn off and allow it to cool off again. It's going to go underneath where you want the temperature to be before it turns back on. And it's going to cycle back and forth and back and forth. Now, with that style system, you need to overshoot your set point temperature before you turn it off. So you may get a 4 degree swing around where you're looking to achieve. If you're looking for 72 degrees, that's going to keep running until it's 74, and it's not going to turn on again until it's 68. And trust me, 4 degree swing, you will definitely feel that. At least my wife tells me she could feel a 1 degree swing. Let me tell you. With our equipment, with heat pump equipment, we actually have the ability to ramp up and slow down our compressors. So we don't need to go full on off. We'll just speed it up and slow it down accordingly to make sure we're keeping really tight around that temperature range. So if you're looking for 72, it's really going to hover between 71 and 73, if not even closer than that. And the best part about that is when you're inside, if you've noticed in the middle of the summer, if you have an older style air conditioning unit, when that turns on, the lights flicker. You're like, oh, what was that? That's because it's drawing so much electricity all at once. It literally needs to divert all the amps throughout your house all at once. You're not going to experience that with heat pumps because it is just a consistent flow, a consistent amount of energy. And with that, that's where you're getting your efficiency gains. So now let's talk about heat pumps in cold climate. With a lot of people say to me, I've heard about heat pumps. They can't handle New England cold. They can't handle New England cold. If that were the case, Charlie and I would be out of a job because we're running around selling these things and promising that they can certainly work. So what has occurred here is technological improvements that have made it so our equipment can work better, faster, for longer in the wintertime. So today, we're able to extract heat from outside air even below -10 degrees. In fact, if you have a system sized at 4 tons, tons being the size of your actual system itself, we will actually be able to supply 4 tons of heating all the way down to 0 degrees. You're not going to lose any heating capabilities with these new technological advancements. And we're able to maintain those efficiencies of around 200%. 200% relative to the 95, maybe even 98% you could get with your furnace or boiler. So with that, backup heat is not even necessary anymore. You don't necessarily need to have a gas furnace as a backup or a boiler pumping that hydronic heat throughout your house. You could have it, and actually they could work in tandem quite well in order to optimize your savings and lower your costs overall at the most possible. But you can have an entire home heated completely with your heat pump, and you don't need to worry about losing that heat in the wintertime. And how this works, let me just talk about the technological advancement that has allowed this to happen. So when it gets colder outside, your temperature is going to drop. And when the temperature drops, your compressor is going to have to speed up. It's going to have to work harder in order to extract that heat from the outside environment. When that compressor speeds up, it's going to start getting hot. Now, 20 years ago, we didn't have any backup plan for when the compressor got hot. Once it got too hot, we needed to shut it off for safety reasons. We didn't want the compressor to blow, honestly. So we need to figure out a way, how do we get this compressor to continue working without shutting off? So we implemented a process which we call hyperheat. If you see this red sticker, you'll see this on heat pumps installed in your neighborhood. That means this unit is able to heat in the cold of the wintertime. So when that compressor gets hot, now we're just dumping a whole bunch of cold refrigerant into that compressor. It keeps it cold, so that compressor can continue to run. You don't need to worry about it shutting off. And that's why we're able to continue heating down as low as -20 degrees or colder. So with that, heat pumps, they can deliver up to 85% of their heating capacity down to -22 degrees. Pretty robust. Now, we're getting into the weeds here. I'm not going to ask anyone to memorize this. I just want to demonstrate what goes into sizing your system. We're going to take into account where you live and what your wintertime conditions look like. With Boston, the Boston climate is about 6 degrees. That's like your typical coldest winter day you'll be experiencing. But if you're up in Burlington, Vermont, maybe you have a second house up there, you go up there for the winter time, it gets down to negative 12 degrees up there. Those two different environments, you need to plan accordingly. If it's negative 12 degrees out, there's going to be a derate on your system. You're going to lose your heating capacity. So in that environment, we would probably upsize your heat pump to account for that derate. So that way, on the coldest day of the year, you're still getting all the heat that you need in that space. In the city of Boston, we don't experience a derate at 6 degrees. So if you need 4 tons of heating, 4 tons of your system would be perfectly good for that system. And we'll do all this whether or not you have a backup system. If you have a boiler or a furnace, we can account for that in our calculation, or we could size it as a sole source of heat. Really, it's up to what this system calls for, what your house calls for, and what you, the homeowner, are looking for in your system. So when it comes to heat pump technology, we have so many things available to us that are really big benefits. Charlie's going to go into rebates, certainly. The efficiencies, those are a huge part of this. We're able to integrate your existing boiler or furnace, so that way you can optimize your system to pay the lowest cost possible throughout the winter time. You're going to save a lot of space using this equipment as well. You can actually reduce quite a bit of ductwork. These are very quiet units, very comfortable units to work with. If you set it for 72, it's going to stay at 72. You don't need to experience those temperature swings. So we have a lot of people available locally who can help you install this equipment. At MitsubishiComfort.com, we have a find a contractor tool. If you input your zip code, you could find all qualified and trained contractors in your area that are trained up on this equipment, and they can help you through the process, help and design a system. So now I'm actually going to turn it over to Charlie, and Charlie's going to go through what that walkthrough process looks like and how you could apply this to your individual homes.
Wow. Thank you, Mike. I mean, that was really a powerful presentation. I thought I knew a lot about heat pumps. I couldn't even scratch the surface. So thank you for that. And all right. Well, Charlie, I
Okay,
guess you're
so
up.
I'm gonna reinforce some of what Mike has said. Um, so my name's Charlie Morelli. I am a residential area manager uh, north of Boston. I'm filling in for Sean Gallagher, who's the south of Boston residential sales manager. Waiting, there you go. There's my slide. Next one, please. So I am going to go over a quick case study. I'm going to do a product overview, some of which Mike has already talked about. I'll get into it a little different. I'm also going to go over the design considerations so people can understand when a contractor shows up at your house, why they're looking for certain information and how you can be ready for those questions. I'm going to talk about Mass Save, give a quick overview on what the Mass Save rebates are. I'm going to talk about IRA federal rebates and give you a resource for that and a quick overview. I'm also going to talk about the hidden rebate, which is the Mass DORE, Department of Energy Resources, actually has another rebate program that nobody ever talks about. So you're getting some secret mystery information here. And then I will take questions. So I'm going to begin by going through a case study. And actually, I use this slide normally just to show people that our hyperheat equipment will work in minus 13 degrees. This is actually an example where it was minus 10, the outdoor temperature at that time, and it's confirmed what time it is and what the actual temperature is. And below, you can see the thermostat was set to 73 degrees. Now it's at 72. That's at minus 10. That equipment that's being used right now by Mitsubishi is rated for minus 5, 100% operation. But at minus 10, it only dropped 1 degree. So if you have any doubt on the ability of this equipment to heat your home, that this should um, help you at least understand that the capacity is there. I don't have a great slide on this, but this is actually an apartment above a garage. That's a 2-car garage. Maybe some of you people have that type of garage with an apartment above it. It's using just one floor mounted, as you can see in the picture under the TV by the plants, there's one floor mounted Mitsubishi piece of equipment that I'll talk about. It has 25 solar panels on this house, on this garage. And the owner doesn't pay anything to heat and cool this garage. He did insulate it to an R90 capacity, so it is super insulated. So you need to, no matter what equipment you have and who makes it, you need to have a good envelope to get the kind of results that you can see here. But that's an example of integrating solar with Mitsubishi to cover your heating and cooling. And heating and cooling, according to the Department of Energy, is 40% of your cost overall for utility costs. So right now, he's getting paid for that heating and cooling. He actually has a surplus every year on this 2-bedroom apartment in this facility. Next slide, please. So Mike had gone over this. I think the main point me and Mike are trying to make here is there are a lot of flexible options, and it doesn't matter what brand. Now I'm going to talk heat pumps in general. Obviously I represent Mitsubishi, so I'm going to bring their information. But all heat pumps have a lot of different options to deploy them in your home. It doesn't have to be just the wall mount. It doesn't have to be just the floor mount. It can be ducted. It can be single. You could just do a porch and have a different heating system elsewhere. You can do a room that's never gotten cold enough or hot enough. You can have a single unit just to take care of that problem. They're very flexible. You can mount, you have opportunities to put ceiling mounts in. You have ducted opportunities, fully ducted. If your house was already fully ducted and you just want to replace what is there, the furnace you had, you can do that. There are what's called mini ducts. You can also duct just a couple of rooms if you have the right infrastructure, and that's why you need someone to come out and take a look at it. Next slide. So this is one of our standard models. It's a very popular model, our FS model. It is a high wall mount. Some of the things I wanted to point to here is dual barrier coating. Mitsubishi has dual barrier coating on our wall mount. What that does, it's stopping the dust and dirt from building up. I don't know if people realize it, but they also have filters in these heads that you do need to clean. I would recommend, depending on your house, if you have pets, you got to clean it more often. If you don't have pets, you could probably do it once a month or every couple of weeks. Just you should open it up, take a look at it. All you need to do is take it out and run it under water and let it dry. Those filters last up to 10 years, so you're not running to the store to get new filters all the time. The FS model has the hyperheat that Mike had talked about that guarantees 100% at -5. In Boston, there's only 32 hours that get below 0 as a temperature. That doesn't count wind chill. A lot of times we feel the wind chill and we think it's below 0 all the time or super, super cold. That equipment isn't affected by that wind chill. The other thing we have on the wall-mounted heads is we have a 3D eye sensor. What that does is it's scanning the room. If nobody's in the room, it goes into an energy save mode. So now you're not using extra energy. And then on the outside condenser, which this is important in Cohasset, we have bluefin coating. What that coating is, it's a protectant on the copper and metal parts from ocean, salt, any degrading wind that they're getting from off the ocean. And Mike had mentioned it, it's operating at just 20 dBA. You know, one of the other things it has too, you can actually mount this normally on a high wall mount. You can only mount it on one side of the room or the other to get the full room suite. The difference is this has a double vane air delivery. You can actually, if you had to put it in a middle wall, you could point each side to get the right airflow for the entire room. So there's a lot of features on this. And this is, wall mounts still are the most popular way that people use this product. Next slide. I think Mike touched on this. This is just showing that at low capacity, it's not going on and off. You're not on a total on and off like you are with a furnace that you may hear it coming on and off all the time. This is going to be nice and steady. We call it cruise control. So it's like your heating goes on cruise control. Next slide, please. This, again, for Cohasset, this is kind of an important slide. We're talking about the Bluefin Hex. This is our anti-corrosion treatment. Again, it helps you from the ocean water. Well, obviously not the water, but the wind blowing off the water. I don't want you to think you can dump this in ocean water. We do have another option I didn't put on the slide, but we can get these bi-gold coated. So if you're really on the water, we can get the equipment bi-gold coated for you. That's like a rubber coating that can really help your equipment last longer. But this is standard. This Bluefin Hex is standard. Next slide. This is an example of a ceiling cassette model. Mike kind of went over this real quick. He showed some pictures of it. As far as design usage, this is mostly used if you have a drop ceiling. So if in a residential and even a commercial application, a drop ceiling is where this is appropriate. I've seen it, you know, it can also be kind of open with the industrial look. It does need, right next to it, you need a trap door for servicing. And it doesn't matter what brand that you're looking at for this type of a delivery device, you definitely need room for it. It's got to be in the proper, it's got to be applied to the proper ceiling. Next slide, please. This is our designer model. A lot of people don't realize that we have these three colors: matte silver, glossy black, and glossy white. You see this a lot of times in living rooms where they want an upscale look. A lot of contractors won't mention this because they just don't realize it's available. So I just put it in here so that we could know as a group that this is another option. Next slide, please. We went over the case study with the floor-mounted unit. The floor-mounted unit is usually used in Cape-style homes. It's good for knee walls. It's used on some porches. It can be recessed into the wall. So if you're replacing radiators, let's say, you can use this. It's a good application. Next slide, please. Mike had brought this up. This is the Easy Fit model. It fits between the joists in your house. So it's very easy. It's very slim. This pretty much can disappear. People won't see it. They'll walk through your house. It'll be very hard for them to even see this because it fits so sleek in the ceiling in the right application. It's great for new construction because everything is open. It's great when you're doing an addition. But it could work as a regular retrofit too. You got to cut into the ceiling and and mount it. It doesn't need, unlike the ceiling cassette that I talked about before, that needs a separate panel next to it to be serviced. This is serviced from the bottom. So it doesn't need anything extra. It's very sleek. There's a lot of YouTube videos out on these models and people putting them in houses, and they're beautiful. We're not the only manufacturer that offers this. So there are other manufacturers you can get this from, and you can go to YouTube, you can watch them, and when you see the results on this, Mike did show one that was very nice, but they show a lot of videos of people mounting these. They just look amazing. Next slide, please. So this is an example. A lot of people don't understand that they can go with a ducted solution. It's not just ductless. We call it mini split, we call it ductless all the time, but we forget that there's a ducted solution, meaning we can work with the ductwork in the house. Now, that said, this is not going to improve. If you have bad ductwork is bad ductwork. You need to get that fixed, or there are processes where you can get your ductwork sealed, and Mass Save will come do an assessment. And sometimes the ceiling, I know in my house, I got the ceiling for free on my ductwork at one point. So you can get a lot of free insulation and just preparation prior to putting in a heat pump through Mass Save. I will talk about Mass Save, but I won't get that deep into those programs. But this is showing you can have a mix also. They did the bedrooms upstairs. A lot of times this is what happens. So you have the bedrooms upstairs. You usually break that into one condenser with the ducted solution. Then downstairs, you can have your wall mounts. You can have all your ceiling mounts. You can have your floor mounts. You can mix it all up. Sometimes you can get it on one condenser. Sometimes it really needs to be two. I feel two is better. A lot of people only want one condenser in the yard. I understand that. But for performance of the equipment, sometimes if your contractor is telling you it's got to be two, it's probably the right way to go. Next slide. Again, I think Mike had shown this, but we can get up to 8 zones per condenser. And we have a thing called a branch box that's shown in the second diagram, that they're using a branch box that's used to help conceal the line height, so your house doesn't look like an octopus lives there or an octopus landed on your roof. So we try, a good contractor is going to try to hide all the line height they can, so that the outside of your house, it's aesthetically pleasing and not all over the place, but you're getting what you need in the house. Next slide, please. So this is a slide from the actual training. We actually do 4 hours of applications training. Usually I spend an hour alone talking about the products to contractors. So our applications training, we go over a lot of the things that they need to know. And it's a lot of technical training. I didn't want to bring the whole thing here, but I want people to understand when they hire a diamond contractor from Mitsubishi, they're hiring someone that's gone through some specific training with us. And they've also, if they're Mass Save certified, they've also gone through training with Mass Save too. So there is a lot of training before they ever enter your house. So a lot of design has to start with load calculations. Load calculations basically is a way of measuring your house and finding out what the heat load is and what the cooling load is for the house based on measurements. It's based on square footage. It's based on questions they're going to ask you. Where does the sun come up? Windows. Are you getting a lot of radiant heat from windows? That's going to affect your AC and your AC efficiency. What way is the wind blowing? There's a lot of things that they ask you that you're not wondering why. How many people are normally here? You know, they start asking these questions. You're almost like, this is kind of intrusive, but no, they're asking these questions so that they can take all that information and they'll plug it into several programs that will help them calculate the load so they can give you the best, most efficient piece of equipment. It used to be, you know, with oil and gas, because I've sold those products, you're primarily selling a heating product, they're more forgiving. You can oversize. And a lot of times we get called out on an emergency and you just have to replace whatever's there. And you usually had to upsize because it wasn't available, whatever was available. You can upsize heating all day long and not have a lot of problems. But when you say cooling is very specific, it has to be very almost down to the BTU. It has to be measured very specifically for you to get 100% efficiency and to get 100% comfort. So after they do the load calculation, they have another software program they use to take the equipment that they are suggesting, run it through that program and make sure that equipment is going to work together. Your local inspector load calculation is a manual J to your local inspector. That's required. Equipment selection, again, to your local inspector is a manual S, also required by the inspector. Confirmation of design and performance, that's done by testing the system prior to them leaving your house, making sure the system is working up to what the rating is. So a good contractor is going to be doing all this, and that's what we're teaching a good contractor. And again, I'm doing this very quickly. We spend 4 hours. I would say each of those subjects alone is an hour just in Mitsubishi training. I'm not sure Mass Save does training too, and I'm sure their training is pretty extensive also. Next slide, please. This is an example, again, from the training and why we need to do training, because we've got 3 houses right here and they're all the same exact square footage. So we can't just we used to just use a calculation of BTU per square footage, like 25. We used to multiply 25 times that number to come up with what our solution was going to be. But you can see today that doesn't work. House number 1 has no insulation. It's a typical New England house before Mass Save went out there, did an energy assessment, did some insulation, and did some upgrades. House number 2 has had some upgrades. Maybe it's got windows, it's got some new insulation. It had an energy assessment. House number 1, I'm sorry, house number 3 is obviously close to being a perfect house as far as they've done their assessment, they've got their windows upgraded, they've got a very tight footprint, and you can see the differences in the numbers that are required to heat and cool that house. So they may look exactly the same from the outside. They look exactly the same from Google Earth, but that's not the way to discover what the house needs. That's not how a good contractor should go out there and determine what kind of heat and cooling load that they should be presenting to you. Next slide, please. So these are all the design considerations they should be looking at. You know, what's the existing system? What issues they should be asking you? Or do you have areas where you feel hot or you feel cold? You should be able to deal with, you know, tell them those different areas. They should be looking at your electrical system. They should be looking up in the attic at your insulation. They should be looking, you know, just poking around and getting a good idea of what what the materials are in the house and where the hot and cold spots are, how much windows there are. So there's a lot of that they go through. And then from there, they start the design process. They look at things, if you've got if you want to go with a ducted system, they got to think about air distribution. Even with a ductless system, they think about air distribution. They got to think about where they're putting the line sets on the house. You know, the electrical panel, they've got to look at the electrical panel. Do we have what we need to power the system? Is there anything we need to do here? Do we want to put, you know, a whole home system in? Or can we not put a whole home system in? They'll look at the utility rebates for that area to also match up with your expectations on what types of rebates you feel you want to get to be able to afford the system. Next slide, please. So the Inflation Reduction Act, IRA. So I'm just going to cover this quickly. This is a federal program. You can get, even if you just buy, you don't have to go whole home with this to get this. This, you can do a partial. If you just did a sunroom and you bought a condenser that qualifies, you can get 2,000 off. I think next slide will give us the information on that. So Mitsubishi keeps up on that. So MitsubishiComfort.com/IRA will keep you up to speed on this and what you need to do to get this 2,000. There's a form you file with your taxes. You file once a year. You have to owe taxes to get the 2,000. It is a credit. It can be carried forward. But that's the first federal program. It's more lenient than the state program in some ways because you can do it with a partial and you still get the full 2,000. Next slide. So Mass Save, this is the Mass Save slide. Whole home, you're gonna get 10,000. You've got to, on the Mass Save site, it'll walk you through all the things you need to do. You need to get an energy assessment. You need to send in the right paperwork. A good contractor is gonna walk you through this and tell you how to get through this. But 10,000 is available. A partial home incentive is 1,250 per ton. And a ton, just so we can measure this, because we talk BTUs and we talk ton, 12,000 BTUs is a ton. So that equals a ton. And there are some income-based incentives, I'm not gonna, that are enhanced, that are gonna get you up to 16,000. That's based on the average income of the town. So there are things that you may think you won't qualify for, but you need to look into that. If you, it's worth looking into, and I would go to the Mass Save site to get deeper into that. But to me, the most important Mass thing that does is gives you a 50,000, up to $50,000 loan at 0% for 7 years. Right now, you could put your money in the bank and make 5%. So getting 0% for 7 years is a larger benefit than it's probably has been in the life of this program. So I can't stress that enough. There is talk that may end this year because these programs are put together to get to a certain level of heat pump, a certain amount of heat pumps out into the market. And when they hit a certain level, they start degrading some of these programs because they feel they've hit those levels. So I can't say it enough. That $50,000 loan is gold. Next slide, please. This is the secret program I talked about. This is from the Mass Department of Energy Resources. Right, the program, the benefit I'm talking about is the small air source heat pump alternative portfolio standard. It's basically, if you're familiar with SRACs for solar, this is basically that type of program. It's administered by a different company, which I have a slide on the next slide. But Mass Save also is administered by a second company, not by the state. These programs are not administered by the state. They have administrators to them. I have the contact information by the administrator. What I would probably do as a group, I would invite the person from this next slide to come on and give a presentation on it. He's a good guy. So go to the next slide. So Tim Graham is the contact. His job is to qualify people for this incentive. It's only paid out 4 times a year. And what he does, he qualifies people. He can qualify heat pumps going back to 2015. So this is a really good program, and I'm sure he's got some commercial. I don't know if Mike's ever dealt with them, but I'm sure he's got some commercial programs too that can help qualify some of the equipment that I know you've got out there as a group and you're putting forward as a group. But that's another incentive program from the state. And that's not dependent on, there is a qualified product list. And I would get more details from Tim Graham on how to qualify it. Next slide. So we're down to questions.
Wow. That was one of the most inclusive educational forums. I can't actually wait to have it be promoted and get out there. I think you've given us a great service to be able to, as the Alternative Energy Committee, to supply people in town with this kind of education. It's really huge. And I'm going to let people in other towns know about this too, because I feel like, the level of knowledge was way above anything I've encountered before. And I know when I had my Mitsubishi, done, it was not probably with one of the trained people. And I don't think that, they went through all of the steps that you're talking about. And of course, I don't think they were all of the, I've had mine a long time. I don't think there were all the options available there are now. So
Probably
I think
not, right.
I think that's really exciting to let people know they don't always have to have that, ductless mini split, but the ceiling. And so I will not talk and see if Steve or Barbara have any questions.
Steve's hand is raised.
Yeah, I've got 2 questions. I think I know the answer to the first one. So is it true that there's no heat pump solution that uses circulating hot water?
Not yet. You're waiting another year to 2. It is in
Okay,
the
that's what
pipeline.
I thought. But
It's
possibly if I wait that long, maybe there'll be a solution out there that we can use our baseboard hot water radiators.
Yeah, there will be. It's in Europe right now. It's been deployed in Europe for years. It will be coming to the US.
Okay. My second question is, we have a air conditioning system on the first floor that has these really chintzy looking aluminum foil wrapped coils as the ducting in the basement. I'm assuming that wouldn't be acceptable for a heat pump system, or would it? And even if it were acceptable, I'd have to put some kind of duct to the bedroom upstairs. Is that practical to do with a?
It depends on do you have room to put ductwork in? Very short runs of ductwork? like in a closet. They can come in just in a closet and put a duct in.
Okay.
And that can cover 2 or 3 bedrooms, depending on the layout of your house. There's ways to come in up a closet and hit all the bedrooms if you've got enough space there. If it's not a cape, you know, and you have some attic space or some crawl space up there, you'd be surprised what they can do.
Oh, okay. Thanks.
I have a quick question. I think it was a terrific presentation. I agree with Deb. It's just, you guys really nailed it. So thank you. So we obviously are big advocates of heat pumps, and we hear that you're telling us that some of the pushback has been resolved, that there's been a lot of positive developments in the last couple of years, right, in the technology. Because what we hear, people that complaining about efficiency ratings, and there's refrigerant leakage, and it depends on how much your electricity cost is, because when the temperature goes down to the 5 degrees below zero, it's not that efficient, right? And it burns a lot more kilowatt hours of electricity. And so people, we're trying to make a case that even if you're not doing it for the right reason, right, to go completely on the grid, on electric grid, we want to make a case that it is competitive on a price cost basis, right? So have you dispelled most of these issues by your upgrade in the technology in the past year or so?
Yeah, I could
think
start with that. Certainly, Charlie, if you don't mind, I could just
Well,
start with.
actually, I had one more slide, Kevin.
Go right ahead if you have the
You're such a
numbers.
show off,
Kevin, do
Charlie.
you have one more slide there? I think I had one more slide that Sean had me put together.
I was gonna
Right.
whip. He has it.
Based on your
It's the
cost.
very last one.
The
Yeah,
very
there
last
it is.
one. I
There
was
it
waiting to
is. I
see if
see it.
Mike was going to use it. I hit it at the end because I wasn't sure if it was in Mike's presentation. But
Yeah.
Sean had asked, Sean had known that was an issue. So this slide is using your rates in Cohasset to show what the cost differences are. And obviously on electric resistant, on oil, on propane, and we're very close to natural gas compared to, if you look at the cost per million BTUs, which is the fastest way to see it. Most of our equipment is between COP 3.5 and COP 4 on our output. Natural gas was 11.9.
And where do residences fit in there? Are 3 to 3.5, or is it dependent on something else? I mean, that's your
That's
energy
dependent to
efficiency
your
rate.
point. When it gets super cold, you're gonna go down in COP. It's the COP level will go down. So that's why we're showing the different COP rates. So you can
Right.
see even in a COP2, that means it's probably below zero at that point. We're at $24, where electric resistance is double at 48. Oil is at 35, propane's at 44, based on the local rates in Cohasset.
Got it. Yeah, that's very helpful. Extremely helpful. Thank you.
Yeah, so I hit it because like I said, I thought Mike might hit that point. The
Right.
other point too, that I've heard that before about refrigerant leaks. Now, refrigerant leaks are probably a thing of the past. It used to be that when you were installing this equipment, you had to braze it, which means take a torch and basically light up a collar around the copper to make it solidify together. Those days are over. There's now tools that automatically do that. So that is a thing of the past, but let me ask you this, because I've heard people say this. Would you rather have natural gas leaking? Because guess what? Natural gas distribution leaks all the time. It's one of the leakiest we have, unless you got brand new distribution pipes there. So that is for global warming, that's not a great thing to have natural gas leaking. As long as you're leaking something, the refrigerant is actually better than natural gas if you're going to end up having to leak something.
Yeah,
So,
as far as it's the CO2 value or whatever, the global warming value.
Yeah,
so
that's
can
great.
I just ask, Charlie, the COP 2, 3, that's a temperature
Correct. So,
value? Because the
so
others are not temperature related, right? I mean,
well, okay. So normally we're running on a good when it's within the conditions of the unit you bought.
yeah,
If it's a 1-to-1 system and it's running in those conditions, it's normally at a COP4.
okay.
If it gets super cold, your COP level is going to start dropping. And we're just trying to be honest and show what the effects are so that because sometimes on a multi-zone you might be at COP3 also, just because you've got a lot of distribution going on from one piece of equipment. So that's also possible. We're just trying to be totally upfront by showing all those different COP levels.
So
and
you could map it out as well, right, Charlie and Mike? You could say, okay, during the course of 2023, based on the average temperature in Massachusetts on those days, you could show us what the cost would have been per month, and then for the full year, based on how the temperature fluctuated, which would be a good grid analysis, right?
that's exactly right. And Debbie, you pointed it out perfectly. The COP, it's dependent on a number of things. Obviously, the way that your system's laid out, multi-zone versus single zone, but the most drastic driver of COP is going to be the temperature outside. As it gets colder, remember that slide, the compressor needs to work harder in order to extract that heat from the atmosphere. It needs to work harder. You're going to be drawing more electricity into it. So over the course of an entire year, in the state of Massachusetts, specifically, I'm up in the Boston area. We anticipate between 3 and 3.5 over the course of an entire year. Now, as it gets colder and it does start to work harder, you're going to approach those COPs of 2. And once you get into that 2 range, all of a sudden, some of those fossil fuel driven heating sources, they become more comparable. They become like from a cost basis, like for like. So that's why if you have that backup system in your home, like in my house right now, I have a heat pump as my first stage of heat, but I still have my boiler with the hydronic baseboard running throughout. If it gets below 15 degrees outside, I switch over to the boiler for a bit. Not the whole day, but I do that just a little bit here and there in order to reduce the load on that heat pump itself. And that keeps my costs low over the course of the entire winter.
Could I ask another question about efficiency? So is there like a steady increase in efficiency, each year or whatever? Or, I mean, because I'm just wondering if my 5-year-old heat pump, which does seem to struggle in the winter, and actually we do just shut it off because it seems to struggle. And I'm wondering now, whether they're just very different.
Yeah, each generation that we come out with, one of the major areas we focus on from a product standpoint is efficiency. We want to make sure that every generation you output, it's more efficient. And that's both from, just work on the technology standpoint and, we're a company here, we sell products and we want to be competitive and everyone's racing to get to the most efficient product. It's actually a good thing that you have so many good products on the market. We all push each other to strive for a more efficient end product. So, a 5-year-old system, I'd say between then and now, you probably have seen notable efficiency gains, anywhere from probably 10 to 15% of an efficiency gain between then and now. And the next generation, that's certainly going to be the case once again.
You think there'll be rebates for people that have older systems? Like with Mitsubishi, I'm not putting you on the spot, but it seems to me that they're going to get more and more efficient. So
Right.
it's
The
like the car
federal
industry.
rebate, I think, will be fine with that. I don't know on a state level if they're going to do that. They're still trying to hit goals to just get out, have enough people with heat pumps and we've talked about that. We'll see, because it's obviously there's going to be a replacement market at some point because the product is actually you know, probably getting out, there's probably people that are 15 to 20 years now. So yeah, I love that question. So I guess we'll have to wait and see from what they're gonna do with that.
Yeah, especially since our Massachusetts requires, I think, 100,000 heat pumps is the goal by 20 by next year, by the end of next year, right? So a lot of
And
heat.
actually, in rethinking things, I think my system is quite a bit older. And, you know, I think that, so I'm terrible with dates. So I want to just say, I mean, I think that you have totally, all the evidence is in that these are really, that they work and they're powerful, you know, to negative degrees. So I think that's really, really a key. And I've been reading articles about how I think they've been adopted in a major way in Maine.
Yeah, Maine is that leading the country.
I think you've dispelled many myths and probably got people pretty excited to consider heat pumps.
Great. Well, thank you for having us,
Thank you very much.
and keep
All
up the
right.
good work.
Thank you
You know.
both. Really appreciate it.